10-15 minutes of questions here, and then pass out this homework quiz and let you guys have at it. That's all the plan for today. Reminder again, the homework set for Sunday is 41 to 48 and then 49 to 62. Okay? Tommy, are you questions?
Can you do 23, please?
23?
Yeah.
Yeah, man, sure. All right, so 23, first step we want to do is eliminate the parameter. It doesn't really matter which one you want to start with, whether it's x or y. So let's start with the x equation. I want to get the t by itself, so we'll divide by -2 and then square root both sides. When we square root both sides, we get a plus or minus. Notice I'm not worried about the negative underneath the radical right now because I also have a variable under the radical. So if like the x is negative, no big deal that there's a -2 in there. The domain and range will sort out all that stuff later anyway, so I don't have to worry about that. What I do then is I'm going to take that and plug it in for into the t in my y equation. So there's that. So there's that. And could you simplify that, clean it up a little bit? Sure, if you rationalize the denominator and did some jazz like that, but like, not a big deal to me. We still got to do the domain and range part, right? Do you still need that piece too? Okay. Aiden, did you have a question on this, or are you going to do something else?
I just had a question, like, overall.
Sure, go ahead.
Like, so you can start with the y equation to find what the t value is?
Yeah, but you'll
when you plug into x, you'll just have to move things.
You'll have to rearrange your
so
part.
y
Yeah. Yep.
Okay.
Yeah. So it's whether you want to deal with the quadratic here now, or would you rather deal with the quadratic when it's a Cartesian form and like getting that to get the y by itself.
Okay.
Either one, you're going to deal with a quadratic at some point, so it's 6 and 1/2 dozen of the other to me. But like, I suppose there'd be some situations where like potentially one way is a little bit cleaner than the other way, but it's not probably much difference. So to do the domain then, we're going to worry about the x equation. So that is -2t, and my t goes from -4 to 3, I think. I'm reading that correctly. Okay. Since this equation is quadratic, I care about 3 possible points. I care about the vertex and the 2 endpoints of the function. So first thing I'm going to do is find the vertex. The equation to find the vertex is x coordinate, or in this case, I guess t coordinate, is -b over 2a. Well, there's no linear term, so the b is 0. And I noticed that t value is inside my parameter, or inside the interval for my parameter, so I do care about it. If that vertex was like 7 or something, I could care less, but it is in the interval, so I do care about that. So I need to find x of -4, x of 0, and x of +3. So the 2 endpoints in the vertex. Sophia?
Wait, so you said you don't have okay,
All right, this is my quadratic.
yeah.
There's no linear term, so the b is 0.
Yeah.
Okay. So let's see, we got 32, 0, and then 18. So my domain is going to go from the minimum, which is 0, to the maximum, which is 32. Okay with that?
Yeah.
Okay. The range is real easy since the y function is linear. What is that? +4. All I care about is the endpoints. So I just do y of -4 and y of +3. So that's going to give me what? -8 and then 13. So from minimum to maximum. And we should be good. Note that, did I need to do eliminating the parameter to be able to find the domain and range? No, man. So even if you get stuck on something like that, you can still do the domain and range parts, right? They're almost 3 independent questions where the work from one doesn't depend on either any one of them. So, Sophia.
For the domain,
Yeah.
what if your 32 be negative? Because
Oh, that's a -2t, sure. Sorry, I missed that it was -2t. My highlighting got all confused. So that's a -18, that's a -32. Sure. Thank you. Yep. Yeah, I got swallowed up in that yellow on me, and I just looked at 2t squared. Whoops-a-daisy. We cool on 23? Jack?
Sorry, one more. Can you touch -32 to 0 and not to... Oh, it's -18. Never mind.
Yep.
Thank you.
Yep, because it was the same mistake, so I had to make both of them negative. Yeah. Yep, no problem. Yeah,
how do you know if it's a parentheses or a bracket?
so I knew that these were brackets because the x value or the t value that generated that point had a bracket, and I know the 0 had a bracket because it was inside of the set, so I know that this would get a bracket also. Does that feel okay? So it's coming from that input set.
So say there was like one bracket, like a
Let's say you want to say hypothetically that this was a parenthesis, then the 32 would get a parenthesis. You're welcome. Aria?
you just have like the linear function of t plus 2x equals 2 and like the parameters that you
Mm-hmm.
the domain and range are automatic.
So the output of that function would be all real numbers also, yes. Whether that function is for the x or the y would depend on whether it's a domain or range, but the output of that function would be all real numbers, yes. If you have a linear function whose input is all real numbers, its output will be all real numbers. Lexi. 44? Sure. So it says, Matt hits a baseball when it's 3 feet above the ground with an initial velocity of 115 feet per second. The ball leaves the bat at 41-degree angle at the horizontal and heads towards a 20-foot fence that is 385 feet away. Write a parametric equations to model the flight of the baseball. Okay. Oh, I think we called this S of t because it's a position. Anyways, x is initial velocity, 115. Cosine theta, cosine 41. T. Y, -16t squared, plus initial velocity, 115. Sine theta, sine 41. T, plus initial height, 3. So that's my part A. Part B says, if no fence or other obstacles were present, find the distance the ball would travel when it first hits the ground. So let's a little picture of what's going on. So here's the ball 3 feet above the ground. Whoop. And it's going to land and hit the ground maybe somewhere over here, right? So I want to know this point. I know the y-coordinate at that point is 0. The x-coordinate, I don't know what that is. So far, so good? To find that, I want the t when the y is 0, and I can use that then to find that missing x piece. Feel good? All right, so I'll plug 0 in for y, because my equations for y and x are both independent of one another. They just depend on t. So this is a quadratic. To solve that quadratic, I'm going to use the quadratic formula. So negative 115 sine 41 plus or minus square root 115 sine 41 squared minus 4 times negative 16 times 3, all divided by 2 times negative 16. When I type this into my calculator, my recommendation for you, I would use the fraction command. So I'm going to do alpha y equals and then pick the first option. And I'll negative 115 sine 41. And then I can't do a plus or minus on my calculator, so I'm going to have to just pick one or the other and then do the other one. I know that I need the minus one, so I'm just going to start with the minus one in the interest of time. And then the 115 sine 41, notice how I put this in parentheses here, because both the 115 and the sine 41 both have to get squared. So I'm going to do the same thing here. So 115 sine 41, and then squared, minus 4 times negative 16 times 3, all over 2 times negative 16. I get 476-ish, nope, 475-ish. And then if I do x of 475, I just plug that into the x function, and I'm donezos. So 412.7. Feel okay? Okay. Part C asks, will it clear the fence? If so, by how many feet? If not, will it be catchable, i.e. 10 feet or less above the fence? So again, drawing a picture of what's going on here. Here's the ball at the start. We hit it. It's going to hit the fence or something. I don't really know. I know at this spot, though, the x-coordinate is 385, because that's how far away the fence is. I don't know what the y is. That's what I'm looking for. But I can use the t value when x is 385 to find that missing y coordinate. So I'm going to plug 385 in for x. So t is just going to be 385 divided by 115 cosine 41. Again, I'm going to use the fraction command on my calculator, so I don't have to muck around with a lot of parentheses. And I can do this all in one line, just like it looks like on my sheet of paper, which is how I prefer to do things. So I get 443-ish. And now that I have that, I can do y of 443. So negative 16, 4.43 squared, plus 115 sine 41 times 443 plus 3. And that'll tell me what's going on.
This time period instead of plus 3.
Oh, thank you. So we'll just do this to clean that up. Nope. Oh, yeah, I just mucked the whole thing. Ugh. All right, let's see. We gotta get rid of that. You gotta get rid of that. I'm gonna need to do... Shoot. All right, so I cleared it. Ugh, Mr. Gulick, you're so dumb. At least Aiden knew what I did. Thanks for paying attention, brah. Oops.
Yeah.
So there we got 22.8. And since that's greater than 20, it's a home run by 2.8 feet. Does that feel okay? So I think, again, drawing the picture and really identifying like what you know and what you're looking for can be really helpful. How you guys feel? Slightly better than you thought, maybe, or slightly better than 10 minutes ago, hopefully?
I'm just scared of that following. I got like 35, 46.
What, Amanda? The range for 17, that's super specific. Sure, we can do that. So 17, the range. So again, this is a quadratic. And I know that the interval is infinite. So again, if I think about the graph of this, I have t and y of t are my axes. Since this is a quadratic, I know the shape of the graph is going to be a parabola. And since the leading coefficient is positive, it's positive 2, I know that parabola is going to open up. So I know that my range is going to go from my vertex to positive infinity. Okay with that? So I just need to figure out the y-coordinate at that vertex. So I know the vertex is negative b over 2a. So that's just 0. So y of 0 is 3. So that's just 3 to positive infinity. No problem. You ready to do this dang thing? All right. Well, you willing to do this thing?